So, welcome students. Let's continue with the new chapter, that is the amines. Okay, the organic compounds containing nitrogens, and in that particular part, we are going to start the new chapter, that is amines. So, what are amines? If we are going to check what are amines, so amines are the organic compound which are containing the amine group, that is NH2 group. Okay, and this is the general formula for the amines RNH2. How the amines are formed? So amines are formed from ammonia. Ammonia where nitrogen is covalently compounded with three hydrogens. Okay, so here when one of the hydrogen from the amine, that is ammonia, is being replaced with a alkyl group, then it will be termed as 1-degree amine if one alkyl group is attached with the ammonia group. Okay, similarly, if two alkyl group are attached, means two hydrogens of the ammonia group is been replaced by the alkyl groups, then it will be termed as 2-degree amine or secondary amine. Okay, this is the primary amine, this one will be the secondary amine, and the last, if all the three hydrogens of the ammonia group is been displaced or replaced by the alkyl group, then they will be termed as 3-degree amine or tertiary amine. Tertiary amine. Okay, so this is the introduction of the amines. Okay, this is the introduction of the amines, and here generally the suffix which is used for the amines, it is generally amine. Okay, amines. And if it is used as prefix, then it is termed as amino. Okay, it is termed as amino. So now let's see some more other different types of classification for the amines. So first type of classification for the amines is the aliphatic amine. Aliphatic amine. So aliphatic amine. Amines in which the nitrogen atom is directly bonded to one or more alkyl group, they will be termed as aliphatic amines. For example, CH3NH2. This is methyl amine. The name of this compound is methyl amine, and it is a type of primary amine. Similarly, if CH3NH CH3 is there, so here the name of this compound will be dimethyl amine. Dimethyl amine. It is a type of secondary amine group. Then next, where all the hydrogens of the amine group is been replaced by methyl group, then it will be termed as trimethyl amine. That is the tertiary amines example. It is the tertiary amines example. Now, the second type of classification for the amines is the aromatic amines. Aromatic amines. So in the aromatic amines, the aromatic group, that is a aryl group or a benzene ring, will be aromatic ring will be attached out there with the amine group. Okay, so here the first example can be benzene ring, which is containing amine as the functional group here. So here the name will be aniline. This is the common name, and the benzyl amine will be the IUPAC name here. Okay, similarly, if two benzene group is attached with the nitrogen of the amine group, then the name of this compound will be diphenylamine. Diphenylamine. It is the example of second degree amines. And for third degree amine, three of the benzene group will be attached with the nitrogen of the ammonia group, like this. So it will be termed as triphenylamine. Triphenylamine, which is the example of 3 degree or tertiary ammonia group. Okay. Next, nomenclature for the amines. So in the nomenclature for the amines, if I am taking the example for the aliphatic groups, there they are generally named as methylamine. If two methyl groups are attached, then it will be dimethylamine. If three groups are attached, then it will be trimethylamine or triethylamine. This can be the name of the compound there. Also, if C2H5 twice and then a long chain is been attached on the next side of the amino group here, then the name of this compound will become N diethyl N diethyl butyl amine. Okay, N diethyl butyl amine, which is showing that with the N group of the amine here, two ethyls and one long chain of the butyl group is attached, and hence here the name will be N diethyl butyl amine. If two different groups are attached with the amino group, that is the amine group here, ammonia group here, then the compound name it will be methyl, then ethyl amine. Okay, the smallest chain it will be taken as the side chain and it will be given as a prefix position, and the main chain name will be given to the longest chain here, which is here C2H5, and hence the name will become methyl ethyl amine. Okay, similarly, if alicyclic compounds such as here we are using a cyclohexane, it is been attached with the amino group, so then here the main chain will become the cyclo group here, and hence the name of this compound will become N ethyl cyclohexyl amine. Okay, N ethyl cyclohexane amine. Next, IUPAC naming. This was the nomenclature for the amines. Next is the IUPAC naming. So IUPAC system, if I am considering CH3, CH2, NH2, so it will be ethane amine, CH3, CH, CH2, CH2, NH2. Here it will be 2 methyl Okay, numbering 1, 2, 3. So here it will be 2-methyl propane amine, propane 1 amine. For alicyclic compound, cyclohexahexane amine. Next, if an alicyclic chain with the substituted chain where amine group is connected, then the name of this compound will be 1, 2, 3, 4, 4, 4 dimethyl cyclohexane amine, CH3 CH NH2 CH2 CH3. Okay, so here the name of this compound will be butane 2 amine. Okay, butane 2 amine. So this is the way of the IUPAC naming structure for the compound. Here we can take one more example for the aromatic group. So if I am considering a aromatic group where the amine group is connected to the chain which is connected to the aromatic group here, then here the aromatic group will be became as the side chain here. So the name of this compound will become phenyl methane amine, phenyl methane amine. Similarly, if the amine group is directly attached to the chain here, okay, that is the amino group here, then the name will be benzene amine. Okay, so like this is the IUPAC naming system for the amines. Now sorry, it will be benzene amine, na? So benzene amine, or the common name you have seen before also, that is that the name was aniline. Okay, if here we will see that the benzene group is attached with the amines group and one more alkyl group is attached to that chain, then the name of this compound will become n-methyl n-methyl benzene amine, n-methyl benzene amine, or n-methyl aniline. Okay, similarly n and two alkyl group are attached, then the name of this compound will be n dimethyl n dimethyl benzene amine, n dimethyl benzene amine. Okay, similarly, if an alkyl group is attached to the benzene group and the functional group there is the amine, then the name of this compound will be 4-methyl benzene amine, or para toluidine. The common name will be para-toluidine. Para-toluidine. Okay, para-toluidine. Okay. So this is the naming for the IUPAC naming for the amines. Now, which kind of isomerisms will be occurred in the amines? Okay, what type of isomerisms can be seen out here in the amines? The first is the chain isomerism. Chain isomerism. Isomerism. So, in the chain isomerism, aliphatic amines containing 4 or more carbon atoms show chain isomerism. Okay, any aliphatic amines which is containing more than 4 carbon atoms, it will show the chain isomerism. So here you can see that butane 1 amine is one isomer. Then next is the 2-methyl propane 1 amine is one of the second isomer, and the third can be methyl propane 2 amine. Methyl propane 2 amine, where we will see that tertiary kind of carbon atom is been attached to the amine group here. Okay. The second type of isomerism which is seen out here is the metamerism. Metamerism, where the number of the carbon atom or alkyl group containing chain, it can be changed out there on the either side of the compound, that is the amine group here. So here one example I can take diethylamine. Then next is the methyl N-propylamine. Then next is the isopropyl methylamine. Isopropyl methylamine, where isopropyl group has become as the side chain here. Okay. Next is the position isomerism. The next type of isomerism here which can be observed out here is the position isomerism. So in the position isomerism here, propane 1 amine can be taken one example. Then next example can be taken as propane 2 amine. Propane 2 amine. Okay. Similarly, the next example is the next type of isomerism is the functional group isomerism. Functional group isomerism. And in the functional group isomerism, we can see that the amines group can be written as N-propylamine, while the same molecular formula can be used for writing the ethyl methylamine, that is 2-degree amine. Okay, this is 2-degree amine. This is 1-degree amine from the same formula, and also the 3-degree amine also. So here you can see that the functional group, that is 1-degree, 2-degree, 3-degree amines have been changed out here. So hence it is also showing the functional group isomerism. Next is the preparation method for the amines. So for the preparation methods of the amines, preparation of amines. The first is the preparation of amines from alkyl halides. And in that, the first method is by ammonolysis of alkyl halides, that is Hoffman's ammonolysis. This method is called as Hoffman ammonolysis. So, in the Hoffman ammonolysis, when an aqueous solution or alcoholic solution of ammonia, it is being heated with alkyl halide at 100 degrees Celsius or 373 Kelvin in a sealed tube, all the three types of amines are obtained, and in this reaction the alkyl halides are undergoing the nucleophilic substitution reaction, in which the nucleophile ammonia displaces the halogen atom and the ammonium salt formed initially gives the primary amine or treatment with ammonia. Okay, so here if I am considering the alkyl group, the alkyl halide as Rx, when it is treated with ammonia in the alcoholic or aqueous solution, okay, in the alcoholic or aqueous solution at 100 degrees Celsius or 373 Kelvin, then the formation of a salt, ammonium salt, is formed out there. Then this ammonium salt is further reacted with the other molecule of ammonia, and it is been converted to amines. That is, if I am using 1 degree here, so it will be converted to 1 degree amine, and with that an ammonium salt, that is halogen ammonium salt. Okay, so if this reaction, that is the amine which is formed out there, if it is continued, then the hydrogen here, okay, the hydrogen there, it will be regularly replaced with the halogen of the alkyl halide, and the alkyl group there, it will attach to that particular amine there, and from 1 degree it will convert to 2 degree, and further it will get converted to 3 degree amine, and at last we will see that here it will convert to a quaternary ammonium salt at last, which will be the final product of this reaction, quaternary ammonium salt. Okay, so here after taking an example we will discuss about the mechanism here. So first, let's first discuss the mechanism, then later we will see the example. So the mechanism here of this reaction. So for mechanism, if we are going to see here, then here the ammonia, which is containing the nitrogen, where it is containing a lone pair of electron, it is been reacted with alkyl halide at 373 Kelvin temperature. So there ammonia behaves as a nucleophile and it attacks towards the alkyl group which is present out here with the alkyl halide. So as the nitrogen attacks on the nucleophile nitrogen here attacks the ammonia as nucleophile attacks on the alkyl group of the alkyl halides, the halogen group just dissociates out the bond with the alkyl group and attains a negative charge. And due to this reason, here what we will see that the formation of a positive charge on nitrogen will take place due to attachment with that of the ammonia. And here the halogen group which have attained the negative charge, it will combine ionically, it will form a ionic compound here with the amine group which is attached to the alkyl group. Then further, when one more molecule of ammonia attacks on the halogen group here, okay, attacks on the halogen group here, and one hydrogen group, okay, one hydrogen from the ammonia group, it will be dissociated from there. So the formation of 1-degree amine and ammonium salt will take place here. Next, when this 1-degree amine is further reacted with one molecule of alkyl group. So here presently the nitrogen will again of the amine group, it will again behave as a nucleophile here, and it will attack on the alkyl group of the alkyl halide, and again the halogen will be dissociated from the alkyl group, and here the formation of 1-degree amine 2-degree ammonium salt will take place. On the further reaction with one more ammonia group here, the formation of 2-degree amine will take place, and one more molecule of ammonium salt will be formed out here. Similarly, when this 2-degree amine again reacts with the alkyl halide, where the nitrogen group again attacks on the alkyl group of the alkyl halide, again the formation of an 3-degree ammonium salt will take place, 3-degree ammonium salt, and further with reaction with the amine group here what will happen, here the formation of 3-degree amine will take place. Okay, 3-degree amine will take place, and with it one more ammonium salt will be released out here. And at last, as no hydrogen is been left out there to liberate with the halogens after the removal of all the hydrogens from that of the nitrogen atoms. So at last what will happen, when it again react with one more alkyl group, and again the dissociation between the halogen and alkyl group will taken place here from the alkyl halide, then the last the compound which is formed out here, it will be an quaternary ammonium salt, which will not further react with any more alkyl halide there. Okay, so this was the reaction mechanism here. Next, here let's take an example. So for example, CS3I, that is iodide, is taken out here. When it is reacted with ammonia at 373 Kelvin temperature, it will form alkyl amine, methyl amine, that is methane amine, which is a primary alkyl, and HI will be formed out here. Okay. Further, this 1-degree amine will react with more methyl iodide to form 2-degree, that is dimethylamine, and further this dimethylamine reacts with one more methyl iodide to form trimethylamine, and which is the 3-degree amine. And at last, this 3-degree amine, it will react one more last time with methyl iodide to form the quaternary iodide salt. Okay, so the name it will be tetra methyl ammonium salt, tetramethyl ammonium iodide salt. Okay, so this is the example for the ammonolysis, or also called as Hoffman ammonolysis. Next, the reduction, the next process is by reduction of nitro compounds. So as the nitro compounds are also containing the nitrogen group here, so there, by reduction of the nitro compounds also we can prepare the amines here. So first is the catalytic reduction. Catalytic reduction of nitro compounds. Catalytic reduction of nitro compounds. So there, when the nitro compounds are reduced in the presence of catalysts such as Rene nickel or platinum or palladium at room temperature only, okay, at room temperature only, that is 298 Kelvin, then the formation of amine, that is the aliphatic amine, and water will take place here. Okay, and if aryl nitrates are used, nitroaryls are used, then also they can be reduced catalytically to form amines, that is aromatic amines with releasing of water. So here, for example, CS3 CH2NO2 plus 6 hydrogen in the presence of Rene nickel, platinum or palladium. So formation of ethanamine plus water will be taken out here. Okay. Next is the reaction of nitro compounds, or reduction of nitro compounds can be done with the active metals such as iron, tin, zinc, etc., and concentrated hydrochloric acid. Okay, so if we are taking the example here, for example, CS3 CH2NO2 plus reduction is proceeded on in the presence of tin and HCl, or iron and HCl there, then formation of C2H5NH2, that is ethanamine plus water will be taken out here. Okay, so here this SN can be used with SnCl2 with the mixture of the concentrated HCl also. Okay. Next is the reduction of the nitro compounds in the presence of a strong oxidizing agent such as lithium aluminum hydride. So there also we can reduce the nitro compounds in the presence of lithium aluminum hydride in the dry ether solution, dry ethereal solution. Then the formation of amine will be taken place, that is ethylamine will be formed out here. The last is the if aromatic nitro compounds are reduced in the presence of lithium aluminum hydride in dry ethereal solution, then their azobenzene will be formed, which is a diazonium compound, but formation of amine will not take place here. Okay. Next is the reduction of nitrile group. Also by reducing the nitriles, that is the cyanides, we can also prepare the amines here. So reduction of nitriles or isonitriles. So here the general reaction, or directly we can say that the nitriles are reduced in the presence of catalyst such as nickel or reducing agents such as lithium aluminum hydride or sodium amalgam with solvent as ethanol. There the formation of amine will take place, that is ethanamine here. Similarly, aromatic nitriles such as benzonitrile, they are also the lithium aluminum hydride or Rene nickel. Okay, this nickel will not be there, only lithium aluminum hydride or Rene nickel can be used out here. And the formation of a substituted benzene group, that is the name of this compound will be benzyl amine, will take place here. Next, if this substituted benzyl amine, if it is further reduced, then more carbon atom will get attached here, and here the formation of 2-phenyl ethane 1 amine will take place. Okay, so this is the reduction of cyanide or nitrile group here. Next is the reduction of amides. Reduction of amides. So amides are CONH2. So here we have to remove this oxygen here, and in the place of this oxygen we have to attach hydrogen here. So using lithium aluminum hydride in dry ether, and then the hydrolysis will be carried out to obtain amines. Okay, so here we will see that the number of carbon atom will be same as that of the amide here. No change or no reduction or increment will in the carbon atom will be seen out here. So for example, CS3 CONH2, that is acetamide. It is been reduced in the presence of lithium aluminium hydride and in the dry ethereal solution. Then the formation of amine with removal of water will be taken place, that is ethane amine, and water will be removed out here. Similarly, if aromatic compound, aromatic amides, it is also been reduced in the presence of lithium aluminium hydride, there also the formation of benzyl amine will take place. Benzyl amine will take place here. The next is the Hoffman bromoamide degradation. Hoffman bromamide degradation. So the amides, okay, primary amines are prepared from amides by the treatment with bromine water in the presence of alkali such as KOH or NOH. The amines forms contains one carbon atom less than the parent amide group here. Therefore, this method is used for degrading, okay, degradation of the amines. So here, for example, or the general reaction I am writing out here. So the general reaction here it is RCO NH2, that is amide group, in the presence of bromine and an alkali. Here we will obtain one carbon less amine group with potassium carbonate, potassium bromide, and 2 molecules of water. So here, if I am using acetamide, then on reacting it with bromine in the presence of potassium hydroxide, here methylamine with potassium bromide with potassium carbonate and 2 molecules of water will take place here. So here you can see that one carbon is less than that of the amide group here in the amine. Okay. So this is the Hoffman bromamide degradation method. So for today, I am concluding the class here only. In the next class, we will see some of the more preparation method for the amines. In that, we will include the industrial preparation method also. And the further part of this chapter will be discussed further. That is the physical and chemical properties of the amines. So for today, I am closing the class here only. We will meet up in the next class. Thank you.